Okay, let's work on test 3 review. Probably it'd be best for you to grab the review, at least be able to look at it online, print it out if you want to, but I'm just going to go through each of the problems here. So, problem number 1 asks you to determine whether that function is a polynomial function. So what you're looking for are exponents. The only exponent in here is a 2. That's a regular number. You're good with any integer, any positive integer. So so this is a yes. This is a polynomial function. The no's would be x to the negative anything, or 1 over x to the anything, any exponent there. This happens to be a 1, but any number will do. Those are both not polynomial functions. And that's pretty much all you have to worry about. So let's look at number 2. We're looking at the leading coefficient test to draw each end behavior. Our function is negative 3x squared plus 3x minus 3. Remember, you're looking at the lead coefficient, or the lead term here, this guy. X squared tells me it's like a parabola, and you know what a parabola looks like. The end behaviors are going up to the left and up to the right. This has got a negative in front of it, so that's going to flip those around. So what we're going to have here then looks like that. The end behaviors will be down to the left and down to the right. If it's a q, this is for any even function, this will work. This one happens to be x squared, but for x to the 4th, x to the 6th, any of that, you're going to have the end behaviors will be up or down, depending on if you've got a negative in front or not. To remind you, if you've got an odd leading coefficient, then that looks like the snake charmer. And so we would be looking at this sort of thing, down to the left, up to the right. But if it had a negative coefficient in front of it, something like that, then you would flip those. It would be up to the left, down to the right. These two sections are from 3.2. I'll let you know as we go, but the first group is 3.2, then the next group is 3.3, etc., as we went through them in class. Number 3 is also from 3.2, and you're factoring this. Nothing fancy here. This is a review of one of the skills that you missed in missing 0362. So first question always is there a GCF, a great GCF? And everybody's got an x, so let's pull out an x. And we're going to have x squared minus 4x plus 4 left over. Keep that x. Let's factor this guy into 2 sets of parentheses. So you know it starts with x's. We're looking at what are we going to do with the signs. You know the signs need to be the same, and they'll need to be negatives. So both of these will be negatives. What 2 numbers multiply to give you 4, that add together to give you 4? That's 2 and 2. So this is fully factored. You might consider combining these two because of where we're going with the multiplicity of zeros and all like that. Okay, number 4. We're looking at that. You're finding the zeros, just reading the instructions off of page 1. You're finding the zeros for the function and giving the multiplicity of each zero. State whether the graph crosses the x-axis or touches and bounces at each zero. So let's see, number 4, we are looking at, it's already factored for you. This is not a 0, you can ignore that. So this is a 0, and remember when it's attached to the x plus or x minus, it's a liar. So x equals 6 here. So 6 is where it would cross the x-axis. It has a multiplicity of 1. Multiplicity of 1, which means it crosses the x-axis. It's going to go screaming through the x-axis. This has also got an x attached to it, so you know that the x equals negative 2. It's got a multiplicity of 3. Multiplicity of 3. So it also will cross the x-axis, but it'll do a little bit of a wiggle thing. We talked about that just a little bit If we had a multiplicity of 2, that would be the kind that turns around. So we don't have any of that in this problem. That would be touches or bounces, we called it both. Number 5, doing the same thing, but this one is not factored. So let's factor out the GCF of x. Let's see, what do you got there at the end? You've got a minus sign, so you know the signs need to be different. You're looking for two numbers that multiply to give you 42, whose difference is 1. So 6 times 7 will do that. Always take the larger of the two numbers and pair it with the first sign you see in the problem. So we'll put the 7 there and the 6 there. And now what we've got is 3 zeros here. We've got an x equals 0. That's a multiplicity of 1. And it crosses the x-axis. Got a multiplicity of I've got an x of -7. That's also a multiplicity of 1. And it will also cross the x-axis. And then you've got x equals 6. Again, multiplicity of 1, and it crosses the x-axis. So just in case you're thinking about it, let me show you what that's going to look like. It's an x cubed function, so we know it's going to be like a snake charmer. So it will lower to the left and rise to the right. We're looking at a 0 there, crossing at 0, a crossing at -7, and a crossing at 6. So this guy's got to, I kind of drew this a little off. Let me extend him out here a little ways. So he's got to come through here. It's a multiplicity of 1, so he'll cross. He's got to at some point come back down here. Again, he's got to cross because 0 is a multiplicity of 1. And then he's going to have to come back up and through here and then go out. So it's like a snake charmer in that it's left side is going down, right side's going up, and it crosses through, and crosses through. On this previous problem, just for grins, we've got a 6 and a -2, and we have got 1, 2, 3, 4 multiplicity. So we know that it is going to, they're all positive. We've got a positive on it. So with 4, that's an even multiplicity. It'll rise to the left, rise to the right. It's going to have to cross here. At the -6, it's got a multiplicity of 1, so it'll cross through. At some point, it's going to have to do this, and it's going to have to do some wiggling, and then go on up there. It's going to do wiggling there. It's going to go down and mess around there. That's that multiplicity of 3. We didn't spend a lot of time talking about that, so remember, you're not graphing these on 4 and 5. You're only worried about the multiplicities. And let's look at the last one on this video session. This will cover the end of page 1. The instructions on this say divide using long division, but we're not going to bother with that. We're going to use synthetic division. It's way more fun. So we need to set up our problem. Remember, that's a liar there in that m plus 5. So we're putting a -5 there. And then put the coefficients for each of the terms, 7, 32, -6, and 45. Bring down the 7, multiply, add these together, remultiply, add these together, and multiply. And we've got a 70 there as our remainder. So remember, each of these, this is where we're looking right now, these will tell us our new problem. This was 7m to the third, so this will be 7m squared minus 3m minus 7 with a remainder of 70 over x plus 5. Remember to change it back to plus because it's got an x attached to it. So when you divide 7m to the third plus 32m squared minus 6m plus 45, when you divide it by m plus 5, that's the answer you'll get, and that is the answer. Okay, we're done with this first one. I'm going to post this. I did not tell you this. Let's see. These are 3.2 for number 4, 3.2 3.2 for number 5 and 3.3 for number 6. So I'm going to post this, and I'll, in the next day or so, I'll post the rest of the review, but we'll do it just a page at a time. Send me any questions, and what I'm really interested in is how could I make this better and easier for you to see, better for you to look at, better for you to learn from. Let me know what you're thinking, and I will talk to you next time.